All right. Well, thanks for hanging in there. We've got quite the lesson in store here. So, in this video, we're going to cover cloud computing. Sounds like a lot, so let's get started right away. So, first off, cloud computing is a general term for anything that involves delivering hosted services over the internet. These services are divided into three main categories or types of cloud computing. We've got infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. So a cloud can be private or public. A public cloud sells services to anyone on the internet. A private cloud is a proprietary network or a data center that supplies hosted services to a limited number of people with certain access and permissions settings. Private or public, the goal of cloud computing is to provide easy, scalable access to computing resources and IT services. This cloud infrastructure involves the hardware and the software components required for proper implementation of a cloud computing model. Cloud computing can also be thought of as utility computing or on-demand computing. So the name cloud computing was actually inspired by the cloud symbol that's often used to represent the internet in flowcharts and diagrams. So, cloud computing actually works by enabling client devices to access data and cloud applications over the internet from remote physical servers, databases, and computers. An internet network connection links the front end, which includes the accessing client device, browser, network, and cloud software applications, with a back end, which consists of the databases, the servers, and the computers. The back end functions as a repository, storing data that is accessed by the front end. Communications between the front and the back ends are managed by a central server, and the central server relies on protocols to facilitate the exchange of all that data. The central server uses both software and middleware to manage connectivity between different client devices and cloud servers. Typically, there is a dedicated server for each individual application or workload. Cloud computing relies heavily on virtualization and automation technologies. The virtualization enables easy abstraction and provisioning of services and underlying cloud systems into logical entities that users can request and utilize. The automation and accompanying orchestration, these are the capabilities that provide users with a high degree of self-service to provision resources, connect services, and deploy workloads without direct intervention from the cloud provider's IT staff. Like we were talking about before, cloud computing can be separated into three general service delivery categories or forms of cloud computing. So we've got IaaS. IaaS providers such as Amazon Web Services, AWS, supply a virtual server instance and storage, as well as application programming interfaces, the APIs, that let users migrate workloads to a virtual machine. So users have an allocated storage capacity and can start, stop, access, and configure the VM and storage as desired. IaaS providers offer small, medium, large, and extra large, and memory or compute-optimized instances, in addition to enabling customization of instances for various workload needs. So the IaaS cloud model is closest to a remote data center for business users. Which brings us to PaaS. So in the PaaS model, cloud providers host development tools on their infrastructures. Users access these tools over the internet using APIs, web portals, or gateway software. But PaaS is used for general software development, and many PaaS providers host the software after it's developed. Common PaaS products include Salesforce's Lightning Platform, AWS Elastic Beanstalk, and Google App Engine. Which brings us to SaaS. SaaS is a distribution model that delivers software applications over the internet. These applications are often called web services Users can access SaaS applications and services from any location just by using a computer or mobile device that has internet access. Now, in the SaaS model, users gain access to application software and databases. One common example of a SaaS application is Microsoft 365 for productivity and email services. As you would imagine, cloud computing has been around for several decades now, and today's cloud computing infrastructure demonstrates an array of characteristics that have brought meaningful benefits for both businesses and enterprises of all sizes. Now, some of the main characteristics of cloud computing include self-service provisioning. End users can spin up compute resources for almost any type of workload on demand. An end user can provision computing capabilities, such as server time and network storage, eliminating the traditional need for IT administrators to provision and manage compute resources. Elasticity. So companies can freely scale up as computing needs increase and scale down as demands decrease. So this eliminates the need for massive investments in local infrastructure, which may or may not remain active. Pay-per-use. Yeah, compute resources are measured at a granular level, enabling users to pay only for the resources and workloads that they use. Workload resilience. So CSPs often implement redundant resources to ensure resilient storage and to keep users' important workloads running, often across multiple global regions. Migration flexibility. Organizations can move certain workloads to or from the cloud or to different cloud platforms as desired or automatically for better cost savings or to use new services as they emerge. Broad network access. Now, a user can access cloud data or upload data to the cloud from anywhere with an internet connection using any device. Multi-tenancy and resource pooling. Multi-tenancy lets numerous customers share the same physical infrastructures or the same applications, but retain privacy and security over their own data. With resource pooling, cloud providers service numerous customers from the same physical resources. The resource pools of the cloud providers should be large and flexible enough so they can service the requirements of multiple customers. All these characters unite to support a variety of important benefits for modern business, including some of these. Cost management. Why is that always at the top of the list? Using cloud infrastructure can reduce capital costs, as organizations don't have to spend massive amounts of money buying and maintaining equipment. This reduces their capital expenditure costs, as they don't have to invest in hardware, facilities, utilities, or building large data centers just to accommodate their growing businesses. Additionally, companies don't need large IT teams to handle cloud data center operations because they can rely on the expertise of their cloud providers' teams. Cloud computing also cuts costs related to downtime. Since downtime rarely happens in cloud computing, companies don't have to spend time and money to fix any issues that might be related to any of that downtime. Data and workload mobility. Storing information in the cloud means that users can access it from anywhere with any device, just with an internet connection. That means users don't have to carry around USB drives, an external hard drive, or multiple CDs to access their data. Users can access corporate data via smartphones and other mobile devices, enabling remote employees to stay up to date with coworkers and customers. End users can easily process, store, retrieve, and recover resources in the cloud. In addition, cloud vendors provide all the upgrades and updates automatically. That saves time and effort. Business continuity and disaster recovery, or BCDR. See, all organizations worry about data loss. Storing data in the cloud guarantees that users can always access their data even if their devices, just like laptops or smartphones, are inoperable. With cloud-based services, organizations can quickly recover their data in the event of emergencies, such as natural disasters or power outages. This benefits BCDR and helps ensure that workloads and data are available even if the business suffers damage or disruption. So, of course, with many pros, there have got to be many cons. Well, let's just say that despite the clear upsides to relying on cloud services, cloud computing carries a few challenges for IT professionals. One of them would be cloud security. Okay, so security is often considered the greatest challenge facing cloud computing. When relying on the cloud, organizations risk data breaches, hacking of APIs, interface, compromised credentials, authentication issues. And furthermore, there's going to be a lack of transparency regarding how and where sensitive information entrusted to the cloud provider is handled. So security demands careful attention to cloud configurations and business policy and practice. So you see, it's not out of the range of possibility. You just got to pay attention to it. Now, cost unpredictability can also come up as a challenge. Pay-as-you-go subscription plans for cloud use, along with scaling resources to accommodate fluctuating workload demands, can make it really tough to define and predict final costs. Cloud costs are also frequently independent, with one cloud service often utilizing one or more other cloud services, all of which appear in the recurring monthly bill. And boy, this can create additional unplanned cloud costs. Lack of capability and expertise. With cloud supporting technologies rapidly advancing, organizations are struggling to keep up with the growing demand for tools and employees with the proper skill sets and knowledge needed to architect, deploy, and manage workloads and data in a cloud. But isn't that why you're here? IT governance. The emphasis on do-it-yourself capability in cloud computing can make IT governance difficult, as there's no control over provisioning, deprovisioning, and management of infrastructure operations. So this can make it quite challenging to properly manage risks and security, IT compliance, and data quality. Compliance with industry laws. When transferring data from on-premises local storage into cloud storage, it can be challenging to manage compliance with industry regulations through a third party. See, so it's important to know where data and workloads are actually hosted in order to maintain regulatory compliance and proper business governance. Makes sense, though, don't it? The management of multiple clouds. See, every cloud is different, so multi-cloud deployments can disjoint efforts to address more general cloud computing challenges. Cloud performance. The performance, such as latency, is largely beyond the control of the organization contracting cloud services with a provider. Network and provider outages can interfere with productivity and disrupt business processes if organizations are not prepared with contingency plans. Building a private cloud? Well, architecting, building, and managing private clouds, whether it's for its own purpose or for hybrid cloud goal, can be a daunting task for IT departments and staff. Cloud migration. This is the process of moving applications and other data to a cloud infrastructure, and that's often going to cause complications. Migration projects frequently take longer than anticipated and go over budget. The issue of workload and data repatriation, and that's moving from the cloud back to a local data center, is often overlooked until unforeseen cost or performance problems arise. Vendor lock-in. Often switching between cloud providers can cause significant issues. This includes technical incompatibilities, legal and regulatory limitations, as well as substantial cost incurred from sizable data migrations. Yeah, so just a few things to think about, especially as we have a look at the cloud service market, because there's no shortage of providers. You may actually have heard of the three largest public CSPs because they've established themselves as the dominant figures in the industry. You've got AWS, GCP, and Microsoft Azure. But there are some other major CSPs, and they would include Apple, Citrix, IBM, Salesforce, Alibaba, Oracle, VMware, SAP, Joyent, Rackspace. So when you're considering a cloud service vendor, certain considerations have got to be taken first. So you've got to look at the actual suite of services because they can vary quite a bit between providers. And business users have got to select a provider that offers the services such as big data analytics or artificial intelligence, the AI services that support whatever the intended use case will be. Although cloud services typically rely on a pay-per-use model, different providers often have variations in their pricing plans to consider. And furthermore, if the cloud provider will be storing sensitive data, physical location of the provider's services should also be considered. Now, naturally, reliability and security should be top priority. A provider's service level agreement should specify a level of service uptime that is satisfactory to client business needs. I mean, you catch my drift here, right? When considering different cloud vendors, you got to pay close attention to what technologies and configuration settings are used to secure sensitive information. I mean, hopefully that's logical by now, after all we've been through. But guess what? Now you know more than you did before about cloud computing. And we're going to have another video. I'll see you then.